If we look at page 2 of the Chapter 6 review, number 13 and 14 uses this. Consider the experiment of tossing a four-sided die followed by flipping a coin with the faces labeled H and T for heads and tails. Okay. They want us to write out the sample space. So think of this. We have a four-sided die and we have a coin. So we have 4 sides on the die, 2 on the coin. There's 8 possible outcomes of the die and the coin, means to multiply. Write it out. All we have to do is the die would be a 1, 2, 3, or 4. And we could have heads with that. Or we could have a 1, 2, 3, or 4 with tails with that. And with this case, let's assume that we're not going to change their order. Here we're going to put the die first, followed by the coin. So we're not going to flip-flop the order on that. Number 14, list the outcomes for the event that there is an odd number and a head happening. Clearly you can see what I circled. There's only 2 of them. So for 14, you would list the outcome, which would be these 2 incidences right here. Okay, 15. Consider the following data. We have the number of people aged 5 and over speaking various languages at home in selected U.S. cities in 2006. So we have 4 different cities listed, and we have they speak English only, Spanish, or other languages, and this is the number of people. Question here, what percent of the people living in Chicago and New York spoke languages other than English at home? This is a contingency table, so we're narrowing it down. We're not looking at all the data. We want just the people living in Chicago and New York. If you add those 6 numbers up, you will end up getting it is 10,177 people. And the question is, what that they spoke other than English, so that would be this language in here, this and that. If you add those up, you're going to have 4,583. And to compute that to a percentage, it's going to be about 45% of the people living in Chicago and New York spoke a language other than English. Okay, number 16. A baseball player has a batting average of .240, which means that he has a 24% chance of getting a hit in each at-bat. What is the probability that the player gets a hit in each of the 3 consecutive at-bats? So if you think of it this way, they're at-bat the first time, and the second, and the third. If you heard me, I said we're going to bat once, and twice, and 3 times. I said and, so you multiply. All you would do in here, their batting average is .240 of getting it. They're going to get this one too, and they're going to get this one too. It's .240 to the 3rd power. And it's going to be approximately 0.0138. This is about 1.38% of the time when a batter goes up 3 times in a consecutive row, they will actually get hits on all 3 of the tries. Just be cautious. I didn't say up to bat first or second or third. It's their consecutive hits, so that's why you would multiply in this case. Okay, number 17 and 18. Particular location has a 16% chance of snow on any January day, regardless of whether or not it snowed the previous day. 17. What is the probability 2 consecutive days with snow? So day 1 and day 2. The probability that it snows is 0.16, and the probability it snows the next day is 0.16. That's going to give us a 0.0256. As a probability, that's about 2.56%. Okay. Number 18. What's the probability of 2 consecutive days without snow? Well, day 1 without snow and with snow. The complement of with snow is without snow. The complement to 16% would be 84%. So we're going to do 0.84 times 0.84. And you're going to get the probability that it does not snow in 2 consecutive days. It's going to be 0.7056. Or about 70.56%. Okay, number 19 and 20. Caden is hanging 7 pictures on a wall in a single row. How many different ways can Caden hang the pictures? If you think about it, picture 1, 2, 3, 4, 5, 6, 7. He reaches over, there's 7 pictures, and he hangs one up. Then there's only 6, then there's 5, 4, 3, 2, 1. This is the same as 7 factorial. And 7 factorial is going to give us 5,040 different ways he can uniquely hang up 7 different pictures. Now number 20, how many different ways can Caden hang the pictures if a certain picture must be in the middle? So I'm not sure which one it is, but let's do this. Let's say this certain picture has to be in the middle, so I hang it up. And then what we're going to do here is we only have 6 left, and then 5, 4, 3, 2, 1. That is 6 factorial, which equals 720 different ways. So if Caden's boss came in and said, put that certain mountain picture right in the middle, then he would have 720 ways to arrange the other 6 pictures. Okay, number 21. There are 10 girls and 15 boys in a 3rd grade class. The teacher chooses 4 students at random from the class to work on a special project. What is the probability all 4 students on the committee will be girls? So we want a probability. So probability is going to be a fraction. I need a certain number on the bottom, and I need a certain number on the top. On the bottom, I want all possible outcomes for this class. The teacher is going to pick 4 students at random. Picking 4 students from this class, he has 25 choices, then 24, 23, and 22. That goes on the bottom of this fraction. And I believe it's 303,600 ways he can choose 4 students from his class of 25. By the way, that would be 25, choose 4. Okay. Now on the top, he's limited. He's just going to look at the girls. How many ways, if he has to have all 4 students be girls, the first student's a girl, second, third, and fourth. There's 10 girls in class, then there's 9, 8, and 7. Multiply that together, you get 5,040. And this fraction here will simplify to give us about 0.0166. So about a 1.66% chance, the probability that if he randomly selects 4 students from class to do this project, they are all 4 girls. So in this last one, we have the same data we had before with the number of people in these 4 cities that spoke various languages. In 22, they want us to find the probability that a person age 5 or over living in one of the cities spoke only English at home. So 5 or over in any one of the cities, that's the entire data here. And that totals to 14,186. That they spoke only English at home. And those speaking only English at home would be this column here. So the fraction for that, I'm going to take the 14,186 on the bottom and then do the 7,342, which is that total. And that comes to be about 0.518. So about 51.8% of the people in these 4 cities speak only English at home. Now the other side of it, number 23, asks this. Let me erase this here. Here we have, find the probability that a person age 5 or over living in New York City. So those are all the people living in New York City. And in this case, that comes to 7,638. What's the probability that I find someone that speaks Spanish or another non-English language? So that they speak Spanish is this, or other non-English language is that. Add those 2 together, and it's 3656. And that's about approximately 0.479. So about 47.9% of the people that live in New York speak Spanish or another non-English language at their home. Okay, so this is the end of the review. 24 and 25 is a subject related to 6.9 that we did skip. Let me know if you have any specific questions.